Hello everybody. So in our last video we finished preparing the body of our vacuum, and in this video we're going to be preparing our parts and our assemblies for our final, and here I am going to say final drawing set. We are really close to being done here, so this will probably be the second to last video that we have as part of this series. Now, there's a couple things that we need to do. Number one is we need to go back in and put our part information into all of our parts. And number two is we're going to need to put some fasteners into our assemblies. So here you're going to see me open up a lot of parts and adjust a lot of part properties. Now, if you didn't do this in your modeling learning assignment document, you are going to need to import the Doan part properties file, and you're going to need to put it into into the correct folder. So once again, just to show you what that is, if you go up to what's it? Is it preferences? I think maybe not. All of a sudden I forgot how to do this, which is great. Nice. Now if you go to Tools, Options, see down here in File Locations, we're going to click Edit All, and we're going to go down to Custom Property Files. I'm going to go ahead and select this, hit Control Copy. I'm going to open up a brand new folder. I'm going to copy paste that address. So here, this address is now the same as this address, which means I can get out of here. And when I go to this address, you will see that I have my my Doan part properties file here. You can get this file from on Canvas. I've put it on Canvas, but you need to drop it into this folder so that it will look for this properties file when it goes to do the properties. Okay, so you may not see it initially. You may need to restart SolidWorks after you do that in order for it to show up, but you will notice that now my custom properties do show up here. So I'm going to be filling this out on all of the parts that I've created at this point. So now what I'm going to do is I'm going to create custom part numbers based on what the part is, based on what assembly that the parts are in. So here, let me open up a text document and a little bit as far as identifying part numbers. Okay, so what basically I'm going to do is if it starts with an F, it's part of the fan assembly. If it starts with an M, it's going to be part of the motor assembly. And otherwise, it's just going to have a generic part number. In here, we'll just do P1, P2, etc. Okay, so that's how I'm planning on doing this. Now, what this means is when you assign your part numbers to your parts themselves, it allows you to identify those parts so that if you go look for inventory, you're looking for a specific part number. If you were making multiple models of a vacuum, you would have a very long part number that you could identify that part for. And you go to your warehouse, look through all of the part numbers that are listed, grab a certain part so that you could use it for assembling this vacuum. So that's important. In any kind of design process, you want to make sure that you have identified part numbers. So here, this file that I opened right now, this is, I actually don't know, this is my 1-inch motor gear. So my part number is going to begin with an M because it's part of the motor. And I'm going to call it M000 3. part description, this is a 1-inch spur gear. For my material, I'm going to go ahead and just make this be cast alloy steel. Hit OK. That will adjust the mass of the object. It is not a custom part. This is actually a part that I could purchase from here. And then as far as the manufacturer information goes, I can go to, say, McMaster or Granger. I'll go ahead and jump to Granger. And I'll go look up a 1-inch spur gear. Okay, now here I can, after I've looked these up, you're going to get a bunch of gear options. Here I can get cast iron. These are miter gears. I just want a regular spur gear. Apparently cast iron is normal. I didn't realize that. Oh, steel. Here we go. I'm going to go with a cheap one. So here, this is a 1-inch gear, face width gear, pitch diameter. There we go. Go ahead and add to cart. Oh, I don't want to add to cart. Why I did that? I'm going to view product details. Here, this is Granger part number. Got that. So I'll go back into SolidWorks and paste that information. Okay. Then I'll hit apply. And now I'm done with this part. So hit save and then open a new one. And we'll just keep going through all of our parts. So this is going to become a very tedious video. I'm going to handle the assemblies all at the end where we put in fasteners. So if you really want to watch me do this over and over again, be my guest. But that sounds exhausting. Here, this is my fan. I'm going to have it be F0003, and this is a 3-inch spur gear. I'm going to have this be cast alloy steel. Save. It is again not a custom part, but I'm going to go back to Granger and look for a 3-inch spur gear. So here, I'm just going to go with the cheapest one, which is down here. You'll notice this is bad practice because I didn't even check to see if these gears work together. In a real design, I would make sure that that's the case, but I'm not spending any time on this right now because I don't expect you at your level to be able to design gears. I mean, shock me, but just trying to run through this. But in a real world, I would actually select gears, and I would probably try to model them a little bit better that are appropriate to this design. I would select real parts, make sure that they mesh, probably order them, test them before putting them into my assembly. I always like to test things out. Now we'll go to our battery. Here, I did save information on this battery. And my part numbers document, which I'm glad I saved, which has all of my information. So we'll just pop this up now. Scroll down to where my battery info is. And see, I'm not seeing a part number. Model number CRG02410M. Alright, so that's what I needed to know. This, my part number, this is just going to be P0001. Part description, this is a lithium ion battery. I already set this as very low density PE because I was trying to get the weight to be less than 12 pounds. In reality, this would weigh maybe 5 pounds because a lot of it's air. So model number CRG 02410M. Hit apply and save. Keep going to the next one. To my body. Now this is a custom part. Unlike the last 3 parts, this would have to be something that is made specific by our company. You'll notice that they don't just sell these down at Walmart. I can't go and buy this exact body because I custom designed it myself. So here, this will be P0002 because my last one was P0001. And this is the, I'm going to make it a nylon plastic vacuum body shell. And we will go to edit material, hit yes. It'll allow me to pick the material. Hopefully. Yeah, I will. So I will go down to plastics. And I'm just going to pick a nylon plastic. Hit apply, hit close. This is a custom part, which means it does not have manufacturer info. Although we could put information about how this would be made. Here I would probably do injection molded. But if you don't know what that means, that's okay. We'll talk about that in later engineering classes. Again, apply, save, open, and we'll go to the fan. Now again, this fan, I am planning on custom making it. I'm probably going to make this out of plastic, just because then for plastic components it's cheaper, it's easier to make. It could just be injection molded all as one piece. So that means that this is going to be a custom part. Here, this will be fan number 0001. Part description, this is the fan. This is the, what's it called? Impeller fan blade. Because basically what makes it an impeller is that it sucks air through the center and it shoots air out the sides. We'll also make this out of some kind of plastic. Scroll down to plastics. And I'm going to make it out of nylon again. It'll be made out of basically the same material. How's that? This would be injection molded. Plastic component again, hit apply, go up here, hit save, and we'll move on to the next part. I told you this was going to be very repetitive. Now I am going to skip the fan assembly and I will come back to that later. Gets a little tedious going back in and editing pieces over and over and over again. You could have done this at the beginning, I suppose, but I didn't tell you to. Part number, this will be part number F0004. I believe that, I can always come back here and change that if there are 2 F0004s. Part description, this is the fan axle. I'm going to go ahead and just make this out of plain carbon steel. This is actually not a custom part. This is just going to be like a 14-inch length of 0.5-inch diameter stock steel. Okay, there's nothing special about it. Hit apply and save. So then we'll go on to the next one. Fan mount. I'm also going to make this out of injection molded plastic. This is going to be a custom part. 0002 part description. This is a connect the fan blade to the frame. We'll again make this out of some kind of plastic. Here I'm going to make this be low density polyethylene because why not? What's life without whimsy? It's a custom part, and this is going to be injection molded plastic component. Hit apply, file save, and go to the next one. So here's the frame. This frame is going to be made out of stamped sheet metal because I made it flat on purpose. This isn't a very complex piece. Everything mounts to this. So this will be part number 0003. Stamped sheet metal frame. We'll just make this out of plain carbon steel. Hit yes. This will be a custom part. And I'm just going to stamp and weld this component in-house. So just put a little note that specified that. And on to the next one. Pretty soon SolidWorks is actually going to die on my computer, so we'll keep going until then. So we finished the frame, skipping again the assemblies, go to the handle. After the handle, we'll do the hose. Alright. So this will be P0004. And this will be an injection molded handle. I'm just going to make this out of plastic. And again, this will be the same polyethylene. This is a custom part. And it's going to be injection molded plastic. And apply. Go and save. Open the hose. I'm going to need to start closing some of these SolidWorks tabs now, or else my computer will start hating me more than it already does. I think I already set the material on this one. Yeah, I set it to rubber. So I'll have to do everything else. This will be P00, I think 5 is where I'm at now. I might be at 6. Yeah, I think the handle was 4. I can always adjust these later if needed. This is a rubber hose. So I already got that set. actually this will just come straight from the manufacturer as a 1.25 inch diameter rubber hose. Apply, hit save, go on to the next one. And my intake, this is part of my fan assembly. So here, this will be F0003. Part description, it's the air intake for vacuum. I'm probably going to make this out of metal because it does actually have to be fairly strong. You'll notice it's pretty heavy because it's kind of thick. Manufacturer input, this will be stamped metal. Well, this will be a die cast metal component. Hit save. Go on to the next one. After this next one, I'm going to close all of my other SolidWorks tabs that I have open. Alright, so here's a motor. Open up my properties. This will be M0001. Part description, this is a, well, this is where I go and look up my information on my motor. So here, I did select the MM702-6 motor. This is a 24 volt, 5500 RPM, 400 watt high torque brushless DC motor. Closing this. 24 volt, 5500 RPM, high torque brushless DC motor. Okay, this is not a custom part because I can purchase it. I'll treat it as if it's plain carbon steel, which is going to assume that it's actually completely solid. Makes it a little heavier than it actually is. Then I go to my manufacturer information, and that's where I write in the MM702-6 McMaster electric motor. Don't know why I just tried to open up Google. Oh look, which one of these is it? MM702-6 McMaster electric motor. Apply. Hit save. And then start closing all of these files. Doop, 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 doop. I'm going to leave the last one open so it keeps SolidWorks open. I'm going to give my computer a little bit of time to rest. You'll notice up at the top, it's cycling through all of the parts that it's closing till it gets to the one that it did not close. And then we'll keep going. Alright, so we finished the motor. We'll skip in the motor assembly and straight to the motor mount. Here my motor mount's also going to be made out of plastic. this is M0002. Part description, this is plastic motor mount housing for the MM702-6 master electric motor. Okay, and we will go to edit material. Yes, this is going to be a custom part, and we're probably going to injection mold this as well. I'll make this out of nylon. 101, apply, close. Injection molded plastic motor mount. Apply, save, and on to the next one. We're getting close to the end. We just have all of these reservoir components to deal with now after this piping. So this piping, I'm probably just going to make it out of plastic. It doesn't have to be metal. In fact, most of these components don't have to be metal. This is going to be P0006. I already have a B005, and this is the piping connection between the fan mount and dust reservoir. We will also make this out of low density polyethylene. Apply, close. This is going to be a custom part, and I'm going to also injection mold it. And apply and save. And now all we have to do is the reservoir components. So I'm going to skip the assembly, go straight to the body, and then we have 4 different ones to do after this. Alright, so, man, I know I said I was just going to have everything else be P1, B2, but I'm going to add an R for the dust reservoir. So we'll go ahead and make this R0001. Part description, this is the dust reservoir chamber. Material, I'm going to go ahead and make this out of, ideally you would make this out of clear plastic, and again you would probably do some injection molding to get it to be nice and clear. Let's see, I'm going to pick this. I'm not sure you can get clear very low density PE, but put a little bit of information there, save, and then keep going. Got a reservoir fiber filter. This piece is just going to be like a cotton mesh kind of thing. Basically that would sit on top of this piece. I think I already gave it a, yeah, no, the material is not specified. I think I gave it an appearance. So this will be R0002, and this is the fiber mesh filter. We'll edit material, yes. I'm going to model this as, even though it really doesn't have like, where would this fall in? Well, it's not metal, it's not plastic, it's not, I mean, we got non-metals, make it out of air, there we go. I guess I'm just going to model this as paper, actually. Apply and close. Why not? This is a custom part. This is a 6-inch diameter fiber mesh filter. Circle. Hit apply. Hit save. And go on to the next one. Alright, so this was 1, 2, so this will be 3, the reservoir flap. Notice how I didn't put any kind of like device to hold this on there. I got tired. There's a lot of things I can do to improve this design. It's very rudimentary. It's intended to basically show you the process of part design and talk through how we make part design decisions. Alright, so part description. This is a thin chamber lid. Okay, we'll make this out of the same material as the last one, which was very low density polyethylene. Because I want it to be lightweight. This is a custom part, and I'm going to have this be injection molded. Why? Because I'm pretty much doing that with all of my plastic pieces. I'm a one-minded person right now. On to the next one. I believe we only have 2 left. One of them is a pin. So we'll go in here. This is going to be our 0004 part description. This is the hinge pin for dust reservoir. I'll just make it out of plain carbon steel. And this is not a custom part because I could just get this and order it from anywhere. I believe I made the diameter 0.25 inch by, I think it's 1 inch long cylindrical metal pin. Go ahead and save. And we have one more part to apply properties to. And that is a foam filter. Here, I think I put like a weird texture on it. Not really sure what. Yeah, like carpet. That's awesome. This will be R0005. This is the foam filter. I'll go up and I will select a foam. Other non-metals. And make this be polyurethane flexible foam. Apply and close. Custom part, it's going to be a 6-inch by 0.75 inch round circle, foam circle. Okay, it could be cut out of like a standard sheet of foam. Something like that. Then we'll go ahead and save. And now, once again, just because I'm surprised SolidWorks has not yet screamed, I'm going to close a bunch of the things that I have open. Also, I no longer need this. Save it and let that close. seeing it cycle through all of the parts that it is closing. Almost there. There we are. So now I'm going to do some fixes to my assemblies. So for my parts, I needed to make sure that all my parts have the right properties. For my assemblies, I need to make sure that my assemblies have the right bolts. Now I tried to use a 5/16 inch bolt on pretty much everything. Or I guess a 3/16 inch bolt on pretty much everything. So what that'll do is it'll say, okay, that's a 3/16 inch bolt, that's a 3/16 inch bolt. And I only really need 2 for this assembly. So how do you insert bolts? Well, first of all, you have to go to the SolidWorks add-ins tab up here, and you have to turn on the SolidWorks toolbox. Okay, got to give it a little bit of time for it to load in the registries and turn this on. This may take a little bit more of your processing power than it did before. You'll notice you have a couple of options that popped up here: beam calculator, bearing calculator. Also something called smart fasteners pops up, but we're not going to use that. Instead, we're going to go to the design library, where now you see the toolbox. In the toolbox, I'm going to be going into ANSI inch, bolts and screws, and I'm just going to start picking screws. Now here for this project, most of what we're going to be working with is going to be machine screws. I would just suggest using some round head screws. Okay, so I'll click on this and drag it out here. You'll notice it looks absolutely massive. It's hilarious. But now it'll allow me to pick a size. Okay, now I did work with 3/16 inch screws. 3/16 does not show up. So instead of doing a 3/16, I'm going to be using a number 12 screw. It's close to 3/16. And then I have to give it a length. Here, this piece here, I believe was 1/2 inch and then 1 inch in, which means I need this to be 1.5 inches. I can always come back and adjust these sizes too. But now that I have it, I'll hit OK. And watch what I can do here. Because these holes align, and because it recognizes that I would like a screw in that hole, all I need to do is click right to the side of that hole, and it will put the screw in for me. There we go. Hit escape. And then I will delete this screw out because I don't need it. And now I've inserted fasteners for this one. I'll go ahead and save it. And go to the next one. So here we'll go into the motor assembly, and then we'll go to our final assembly and look to see where all we need our screws and bolts put in. So motor assembly. Here we had 4 really long bolts. So here, let me quickly measure this whole diameter, 0.16 inch. Okay. So I'm probably going to use a number 10 screw, and it's just going to be friggin' long. So again, going back to my machine screws, I'm going to do a round head screw. I'll zoom out here, drag it in. Instead of number 1228, which we now have a few of those in our design, I'll do number 1024. I'm gonna make this like 4 inches long. Oh, I don't think it'll let me. Oh, that's sad. I wonder if it'll let me if I do a 1032. Nope. Apparently 1.875 is the biggest size bolt you can get. Which is okay. I can screw in from the top side here, and then I can screw in from the bottom side. So what I'll do is I'll just use 1-inch bolts that are 1024, and then I'll just use 8 of them here, and then 8 of them when I assemble it to the frame. So just keep that in mind, hit yes, and then this will allow me to put in my bolts. One there, one there. Well, I guess these are machine screws. Look at how massive the heads on these screws are. It's just obscene. This dramatically simplifies the process of putting in fasteners, and it also gives you standardized parts that show up in your bill of materials, which is what I want. All right, now I will delete out that one screw that I don't need. And then we'll go in and file, save this. And as a last piece, we're going to put all of our screws into our final full assembly. So go ahead and open the full assembly drawing. I don't think I had any screws in my dust reservoir. Everything just kind of sat together, so that's nice. I minimized the number of screws I needed for my project overall. Here it's updating because it has to add in a whole bunch of bolts I just put in. Okay, so we got some screws. Sometimes I dislike the orientation in SolidWorks. All right. First things first, I'm going to go ahead and hide this body component. Oh. So that'll allow me to see this. I'm going to go into my design library. I've already got my round head machine screw selected. This is the same exact screw that I had, which was a 1024 screw, 1-inch length. I'm going to go ahead and put 8 of them down in here. As I said earlier, to think that with a single click, I'm inserting a standardized component. Sure is fun. Thanks, SolidWorks. Okay, so that's all I needed from those. I'll go ahead and delete out the screw that I just put in initially. I'm gonna make sure I didn't do that. Now I don't need any screws for my fan assembly because it was actually going to, my fan assembly actually mounts through my frame. But I do need some screws down here for my piping. So again, this is going to be a 3/16 inch number 12 screw. So I will go into my pick a round head screw again, because you know what? I just like round head screws for some reason. I want this to be number 12, 24. I think I made the last one like 1.5 inches, so I'll just use the exact same screw. Hit OK. And plug one in there. And plug one in here. And that's it. We've now mounted all of our screws. I gotta find that one screw. There you are, way over there, buddy. Mounted all of my screws. You'll notice they show up down here as screws, which is kind of cool. But that's it. Oh, I need 2 more screws up here. Aw, dang. I'm gonna use the same size screw again. Once again, just hit OK. Whew. I may need to hide some components. I can see this thing. It is all the way up there. So yeah. Let me hide my motor real quick. Yeah, cancel. There we go, now it's transparent. Where are the holes for my handle? Isn't it just like right there? I'm having a hard time seeing it. Well, guess I'm gonna have to also hide the fan assembly. Change transparency. There it is. There's one of the holes way down there. I saw you. Hard to find though. That means the other one's gonna be right around here. Oh, trying to put one over here. Yep, that looks like a hole. There we go. Make sure I put those in. Yep. And this one here. I assume is this component down here, which I will then delete. So I have all my screws in. I have all my components in. I'm going to go back in and change my transparency real quick. And we will be discussing how to professionally display these components. So change transparency again. Oh, show me components. Oh, apparently I changed transparency on that. Yeah, my bad. There we go. Sweet beauty. File and save. Save all. In the next video, I'm going to be showing you how to professionally display